Hey everyone, in this video we're going to go over problem C on page 47. So problem C says 2 cosine squared x plus 3 cosine x plus 1 equals 0. Now immediately you probably noticed this problem has a little bit more in it than the other ones we've been solving. It even has 2 trig functions, cosine x twice. So even though this problem looks a lot more challenging than the other ones, it's not that bad, so long as we remember a few things about solving equations. So the first thing I'm going to do is replace cosine with our variable x. But first I'm going to turn over our page so we have more room to write on. Okay, so again, we're going to replace cosine with a variable x, like we did in the last problems, just to make solving the equation easier, because we're more used to working with variables than we are with trig functions. So I'm going to say x equals cosine x equals cosine x. And again, I'm making this x red to distinguish it between this one, because these are not the same variable. This x is an angle on cosine. This is what we're just going to call cosine. Okay, so now let's go ahead and rewrite our equation using x for cosine. So we have 2 cosine x squared. Since we're replacing cosine with x, we're going to say x squared instead. 2x squared plus 3. Again, we're replacing cosine with x. So now we have 3x plus 1 equals 0. Just bring everything else down. Okay. Now when we solve this problem, when we finish, we need to remember to replace our x with cosine in order to solve the rest of the problem. But first, let's see what we have. So we have 2x squared plus 3x plus 1 equals 0. So you might recognize the type of equation this is. This is a quadratic. Remember, in order to solve a quadratic, we need to use the Punnett square. Now, I know it's been a while since we've used the Punnett square, so we might have to review a little bit. So let's go ahead and draw our Punnett square. Okay. Remember, we're going to put in our equation along the diagonal here. So the first box is going to use the first term, 2x squared. So write 2x squared in the first box. And in the second box, the middle box, we're going to put 3x, the middle term. And then in the last box, on the long diagonal, we're going to put the last term, positive 1, or just 1, same thing. Okay. Now in order to do the Punnett square, we need to find 2 numbers that multiply to get 2x squared, and 2 numbers that multiply to get 1. So let's start with 2x squared. 2 numbers we can use for 2x squared would be 2x, and I'll use x, because 2x times x gives us 2x squared. So we're going to try this. And then for 1, 2 numbers that multiply to 1, positive 1, we can just use positive 1 and positive 1, because positive 1 times positive 1 gives us positive 1. Okay, now let's see if it works. So we're going to fill in the rest of the squares by multiplying 1 times x. 1 times x gives us just x, or 1x, same thing. And for this box, we multiply 2x times 1. 1 times 2x is just 2x. Okay, and do these 2 numbers add to give us the middle term? 2x plus x gives us 3x, so it works. That means our answers for our Punnett square are right here. The 2 equations on the sides, on the outside. 2x plus 1 and x plus 1. Now, we need to solve those equations. So let's go ahead and write them down here. So I'll go ahead and write the top equation first. So 2x plus 1 and remember we're going to set it equal to 0 in order to solve it, and because our original equation was equal to 0, and we just factored it. And our second equation is x plus 1 equals 0. Okay. So now we need to solve both of these equations by getting x by itself. So I'll start with this one. So in order to get x by itself here, we want to first subtract 1. So minus 1 on both sides, because what we do to one side, we have to do the other. That gets rid of our 1 there, because 1 minus 1 is 0. We can bring down our 2x. 2x. Bring down our equal sign. Then 0 minus 1 gives us negative 1. Okay, now I just want to get rid of the 2. Since it's being multiplied to x, we do the opposite, which is division. So we divide both sides by 2. 2 over 2 is just 1, so it cancels out. And that tells us our x equals negative 1/2. Okay, now let's go ahead and solve the other one for x. In order to get x by itself, we want to get rid of the 1, so we're going to subtract 1 on both sides. 1 minus 1 is 0, so 1 cancels out. We can bring down our x. We get x equals 0 minus 1 is negative 1. So x equals negative 1. Okay, so it kind of feels like we're done, but we need to remember that x is actually cosine. The only reason I changed it was to make solving it a little bit easier. So instead of working with cosine, we were working with x. So now we need to go back and replace our x's with cosine x. So cosine x equals negative 1/2. And cosine x equals negative 1. Again, I just replaced our x's with cosine again. So now we have cosine of x equals negative 1, and cosine of x equals negative 1/2. Now it looks a lot like the problems we've been doing. So that's just at what angle is cosine equal to negative 1, and at what angle is cosine equal to negative 1/2. So let's go ahead and look at the unit circle. And I'll go ahead and look at this one first. So what angle is cosine equal to negative 1/2? We know that cosine is negative on the left side of the unit circle because cosine is our x-coordinate. X is negative on the left side. So let's look for negative 1/2 in the x-coordinate, or cosine. It looks like we have negative 1/2 right here at 120 degrees, or 2 pi over 3 radians. That tells us x can equal 120 degrees, which is the same thing as 2 pi over 3 radians. Cool. But cosine can actually be negative 1/2 at one more point, because we know we're on the left side still. We found a negative 1/2 in quadrant 2. Negative 1/2 is also in quadrant 3 for cosine, right here, at 240 degrees, or 4 pi over 3 radians. So x can also be 240 degrees, which is the same thing as 4 pi over 3 radians. Cool. So x equals negative 1/2 at 120 degrees, or 2 pi over 3 radians, and cosine equals negative 1/2 at 240 degrees, or 4 pi over 3 radians. We're almost done, but now we need to figure out where cosine is negative 1. So let's go back to our unit circle. Cosine, again, is negative on the left side, and we just need to figure out where our x-coordinate, or cosine, is negative 1. And it looks like that happens right here at 180 degrees or pi radians. That tells us that x equals 180 degrees, which is the same thing as pi radians. That tells us we have 3 answers for our angle x. Right here. So x, our angle, can be 120 degrees, or 2 pi over 3 radians, and 240 degrees, or 4 pi over 3 radians, because at those two angles, cosine is negative 1/2. And cosine can be 180 degrees, or pi radians, because at that angle, cosine is negative 1. Okay, that's it for problem C. In the next video, I'll go over problem D in example 2, the last problem on page 47. Until then, see ya.